Hello dear students, myself Meena Labde, Assistant Professor in Mathematics, Department of Mathematics, Maharaja Jivajirao Shinde Mahavidyalaya, Srigonda District, Ahmednagar. Now in previous lectures, we have seen S.Y.B.Sc Mathematics Paper 2nd, Numerical Methods and its Application. It's unit number 1. The title was Solution of Algebraic and Transcendental Equation. Now we are going to see unit number 2, Interpolation, and this is first lecture of unit number 2. Let us see what is meant by interpolation. So interpolation is a type of estimation, a method of constructing new data points within the range of discrete set of known data points. So recall again, interpolation is a type of estimation, the method of constructing new data points within the range of given discrete set of known data points. So consider the tabular values x1, y1, x2, y2, x3, y3, etc. xn, yn, which satisfies the relation. Let me highlight this. So which satisfies the relation y is equal to f of x. The method of finding the values of f of x corresponding to certain given values of x is known as interpolation. So we have to find the values of f of x satisfies to the given data. So let us define forward difference and backward differences. So in interpolation, difference operator are very important. Let us see forward differences and backward differences. So consider the function y is equal to f of x tabulated for the equally spaced arguments. So it is x0. You may call x1 as x0 plus h. You may call x2 as x0 plus twice h, etc. xn is x0 plus nh, where h is the increment in independent variable x called as the interval of differencing. Now the value of f of x, you call this as y0. Then y1 is f of x0 plus h, y2 is f of x0 plus twice h, etc. yn is f of x0 plus nh. So let us see the forward difference or leading differences. The first forward difference is denoted by, let me highlight this. The first forward difference is denoted by this operator delta, and it is defined as delta f of x is f of x plus h minus f of x, where delta denotes the difference operator, forward difference operator. In particular, what will be delta y0? Delta y0 is y1 minus y0, delta y1 is y2 minus yn, etc. In general, you will get formula for forward difference table. Delta yn minus 1 is yn minus 1. Next, if you take the difference of this first forward difference, then you will get second forward differences. The second forward difference is defined as delta square f of x. It is nothing but delta of, I have mixed here delta, so here is delta of delta f of x. So it is delta of, it is already written here, so I want to erase this. Let me erase this. So delta square f of x is nothing but delta of delta f of x. Now in bracket, this is your delta. It's very difficult to write in on screen, but I am trying, so bear with me. So this is delta f of x. So delta of delta f of x, so we have already seen the definition of delta f of x. This is f of x plus h minus f of x. Now you can operate delta inside because we have delta is a linear operator. So delta f of x plus h minus delta f of x. In particular, let me erase this. So in particular, you will get delta square y0 as delta y1 minus y0. Delta y1 is y2 minus y1 minus, in bracket, y1 minus y0. So that become plus. So y2 minus 2y1 plus y naught. On similar way, you can find delta square y1. If you take difference of this second order forward difference, then you will get third forward difference. The third forward difference is defined as delta cube f of x is delta square in bracket. This is nothing but your delta f of x. So delta square f of x plus h minus delta square f of x. In general, the nth forward difference is delta, this is important, delta raised to n f of x is delta raised to n minus 1 f of x plus h minus delta raised to n minus 1 f of x. So remember this first forward difference. And the forward difference table is, so first column gives you the argument, that is values of x. So these are x naught plus h, x naught plus twice h, x naught plus thrice h, x naught plus 4h, etc. Whichever values are given, you have to write in the argument column. Then entry values of y are also given. So y naught, y1, y2, y3, y4, etc. So remember, for computing this forward difference table, you have to use alternate lines, because in between lines you are going to write these forward differences. So use alternate lines to enter argument and entry y. So first column is delta y. So delta y, how to compute? So here is delta and this y1. First take y1 and then y1 minus y naught. So that gives you delta y naught. So because delta y naught is y1 minus y2. So remember how to take difference. It's succeeding minus preceding value. So पुढचा वजा मागचा. So remember this. So this is delta y naught is y1 minus y naught. Now this difference of these two you have to write in between. So this gives you delta y1 and this is पुढचा minus मागचा. So y2 minus y1. So this is your delta y1. Then difference of y2 and y3 you have to write in between. So that gives you delta y2 and that is y3 minus y4. y4 minus y3 gives you delta y3. In the next column is for second forward difference, delta square, the differences of first forward difference. Now this is your delta y naught and this is your delta y1. So we take difference succeeding minus preceding. So पुढचा minus मागचा. So delta y1 minus delta y naught, you will get delta square y naught. Similarly, delta y2 minus delta y1, you will get delta square y1, and delta y3 minus delta y2. Now these values we are going to consider, and that gives you delta square y2. Again, the third column is third forward difference. So differences of second forward differences. Now this is second forward difference, this is second forward difference, and take their difference. So succeeding minus preceding. So delta square y1 minus delta square y naught, that gives you delta cube y naught. Again delta square y2 minus delta square y1, that gives you delta cube y1, and these are the two values. So fourth forward difference is the differences of third forward difference. So this is delta cube y naught and this is delta y1. So delta cube y1 minus delta cube y naught, that gives you delta raised to 4 y naught, etc. So you have to continue like this, and this is called as a forward difference table. So let us see an example. So construct the forward difference table from the given data. Also find the values of delta square y at 15 and delta square y at 10. So these are the suffices, y suffix 15 and y suffix 10. So the argument values are given 5, 10, 15, 20, 25, 30, and respective y's are given. So let us compute forward difference table. So first column is for argument. So this is argument x. Second column for entry y. So whatever data is given, you have to write in argument and then you have to write in entry y. So the values of argument 5. So wrongly I have written here x naught. It's not x naught. It is x1. So you should write this as x suffix 1. So x1 is 10, then x2 is 15, x3 20, x4 25, and x5 is 30. So entry y0, y1, y2, y3, y4, y5, you have to write this. So remember this, to write entries you have to use alternate lines. Now in between these two lines you have to take the difference, and difference कसा घ्यायचा आहे, पुढचा मायनस मागचा. So succeeding minus preceding. So compute, make this calculation here, y1 minus y0. So 948 minus 9962. So that gives you minus 114. Next in between, so difference of these two you have to write in between. So difference, how to take difference, पुढचा minus मागचा. So 9659 minus 9849. So that gives you minus 189. So continue like this, y3 minus y2, that gives you minus 262. Then y4 minus y3, that gives you minus 334. And y5 minus y4 gives you minus 403. So check whether these calculations are correct or not. So this is the column for first forward difference. Next column, delta square y. So delta square y, so difference of first forward differences. So difference कसा घ्यायचा आहे लक्षात आला, succeeding minus preceding. So minus 198 minus minus plus 114. So that gives you minus 75. Difference of these two you will get minus 73. Difference of these two gives you minus 72. And difference of these two gives you minus 69. Next column is for delta cube y. Again differences of these difference. So these two minus 75. So first take minus 73 minus minus plus 75, and difference of these two is plus 2. Then difference of 73 and 72 is 1. Then minus 69 minus plus 72 is 3. Then again difference of these 1 minus 2 is minus 1, and difference of 3 and 1 is 3 minus 1 is 2. So that gives you delta raised to 4 y, and the last is delta raised to 5. So 2 minus of minus 1, that gives you plus 3. So this is the first forward difference. Let me erase all these. So you perform this calculation at your own and check whether these are correct or not. So this is forward difference table. One more thing we have to do here, we have asked to find, this is not x0, this is x1. So from the table, now see, when you have prepared table like this, so in the entry, very first entry is y0, then go diagonally, so that gives you, this is your delta square, sorry, delta, this value is nothing but delta y0, then delta square y0, then this is delta cube y0, delta raised to 4 y0, and delta raised to 5 y0. Again this is y1, so this is your delta y1, this is delta square y1, this is delta cube y1, and this is delta raised to 4 y1. This is y2, so that gives you delta y2, this is y2, so that gives you delta y2, go diagonally, this is delta y3, and this is delta y4. Now y3 is nothing but y at x equal to 3. Now this is x0, x1, x2. So y suffix 15 means y at x equal to 15. So y at x equal to 15 means this, and we have asked to find delta square y2. So this is delta y2, and this is delta square y2. So this is nothing but minus 72. So delta square y suffix 15 is minus 72. Now what is delta raised to 4? Y10. So y10 is y suffix 10 means this is y1, and we have to find delta raised to 4 y. So y at x equal to 10. So x equal to 10 is y x equal to 1. So that gives you y1, and we have to find delta raised to 4. So this is y1, so this is delta y1, this is delta square y1, this is delta cube y1, and that last 2 is nothing but delta raised to 4 y1, that is delta raised to 4 y10 is equal to 2. So we have constructed this forward difference table and we have computed the values which we have asked. So this is an exercise for you. Construct a forward difference table from the given data. So just find out the column for delta y, delta square y, delta cube y, etc. And you may compute delta square y2, delta y, delta square y at x equal to 15, delta y at x equal to 4, etc. You may find anything. So just prepare the forward difference table. So this is all about forward difference table. Now in next lecture we are going to see backward difference table. So thank you. Thank you.